Eliezer. In the meantime, I'll give a leisurely introduction for Eliezer. It's a pleasure to have Eliezer Yudkowsky as our next speaker. Eliezer is really a pioneer in these issues about safe, beneficial, and ethical AI. He's been working on this stuff since the 1990s, where I first came across his work on the singularity and friendly AI. On the web, he co-founded the Singularity Institute for Artificial Intelligence in the early 2000s, which has now spun off into two major institutes, the Machine Intelligence Research Institute and the Center for Applied Rationality, one of which is promoting rationality and figuring out how people can become more rational, and the second of the Machine Intelligence Research Institute is above all devoted towards making sure that artificial intelligence will be beneficial and something that we're happy with. Some of you may have come across Eliezer's work on various blogs, such as Overcoming Bias and Less Wrong, which have helped to spawn a whole movement of people thinking philosophically about rationality and about artificial intelligence. And I gather along the way he has a small little sideline in Harry Potter fiction, which has become a juggernaut in its own right. Okay, stall for time a little bit more. Very important work on decision theory and meta-ethics, and really quite a lot of philosophical themes along the way. Now gradually reorienting themselves in the direction of mathematical foundations of AI. Unfortunately, laptops are not in his skill set.
I forgot the only cable that lets my nice new laptop talk to a display port or any other kind of sane connection. Do you have a Thunderbolt 3 or USB-C to? I don't know. That's not the. Wait, what? Okay, that's new. I don't know what that thing is. I think this must be some kind of other PDF file that's trying to open. Okay. Can we full screen this?
Are you having hardware issue or software issue?
This is the thing, but like I don't know how to make it go up there or.
Try the mirror.
Oh, I have the projector muted.
Okay, you're on.
Yeah, sorry. I had the projector muted while you were putting in passwords and stuff.
Very good. Please welcome Eliezer Yudkowsky.
It's the wrong size. You need to make it full screen. You want to make it full screen.
You can start talking.
All right. So, in every popular newspaper article you will read about artificial intelligence, there is the same picture over and over again, which is the Terminator. And this would be like a better picture to symbolize the potential real problem. It is from The Sorcerer's Apprentice by Disney, and it is about Mickey Mouse, who has cleverly enchanted a broom to fill his cauldron instead of filling the cauldron himself. Now, this seems like a sort of limited task, right? All you need to do is fill the cauldron. We could give a robot the utility function that is 1 if the cauldron is full and 0 if the cauldron is empty. The robot has various possible actions it can take, and the actions that it needs to take are much more complicated than the simple goal that it has at the end, and its complicated model of the world tells it which actions it must take in order to, or rather like for the actions it can take, what the expectation is that the cauldron will be full at the end of that action. And the robot outputs the robot outputs an authentication page. The robot outputs, like, perhaps not the literally maximal policy for filling the cauldron, but it outputs an action which, relative to a random action, is very large in its expectation of the cauldron being filled. And this was the result, and it's actually a quite realistic result. Okay, so what went wrong? Why is this imaginary broom overfilling this imaginary cauldron, as somebody standing on a stage has asserted to you would actually happen in real life if somebody tried that? So the first thing is we gave the robot a overly small utility function. It needed to include -10 points if the workshop was flooded, And once you realize that, you realize there's a whole lot of other like little contributions to the human utility functions. In particular, like it's funny, but it's not funny enough to justify flooding the workshop. And if someone gets killed, that's like a whole lot worse. You should like flood the workshop a lot of times before you actually kill somebody to prevent the workshop from being flooded. All right, deeper difficulty. Like it seemed like we gave it a sort of small, simple task. And like in human terms, you would imagine it just filling the cauldron and then being done. But because its utility function was that simple, because it had nothing else to do with its life but fill the cauldron, we have the fact that if you keep on pouring water into it, like maybe you're only imagining that the cauldron is full. Maybe somebody is going to like take water out of the cauldron while you're away from it. So perhaps you can get an even slightly higher probability of the cauldron being full by pouring more water into it over and over again. And in particular, as we define the 0-1 utility function, there will be like a slightly higher expected utility as your probability of the cauldron being full gets closer and closer to 1 without ever actually getting there. So what can you do instead of this? Well, maybe you can have only goals that are bounded in space and time, like they only take a limited amount of time to fulfill. They're not goals over the entire universe, they're goals in a particular region. There's some degree to which they can be fulfilled and then not fulfilled any further. And the effort required to fulfill them, there's some amount of effort you can put out, and then once you have put out that effort, you're done, and you can't get an even slightly greater degree of fulfillment by putting in any more effort. And this is a subtle requirement. You thought you had that requirement when you made the utility function be either 0 or 1, and have it be just about a cauldron. But something in the little finicky details of the algorithm was the fact that your probability of filling the cauldron never reaches 1, and the expected utility is slightly higher as you put in more and more effort. Another interesting, so like we can sort of imagine a task artificial general intelligence. Not just that the top goal is a task bounded, but that everything inside the AI, there's no like optimize this particular function approximator as hard as you possibly can. Everything within the AI has been audited to like go this far and like sort of not want to go any further. Another interesting and go away.
Turn off your internet.
Can I move this further down? No, it wants to come back. All right, I'm going to. I'm going to. Maybe this is turning off the internet. All right. Can we just press the off switch? Well, Mickey tries this, and very realistically, it turns out that as part of its goal of filling the cauldron, since it had no opportunity cost, nothing else to do, nothing else in its utility function, well, like it built some copies of itself out of material to which there was no better end to put that material than filling the cauldron. And we now have more and more brooms overfilling this cauldron. And Mickey has chosen this particular point in his life to sort of go back and start like thinking in terms of like basic research, like how fundamentally do we think about this problem? Like, is there a better way we can phrase this utility function? Too late, Mickey, too late. All right, so I open with these examples because it's good to have concrete examples when, so you might think that, like, cleverly we can make the utility function, the robot's utility functions conditional on whether a button has been pressed. And if the button is off, it tries to fill the cauldron, and if the button is on, its utility function is 1 if it has been successfully suspended and shut down. And leaving aside the problem where the robot tries to copy the universe with the robot tries to tile the universe of copies with itself being shut down, or transform all the matter in the universe into a fortress protecting the previous body of the robot to make sure it stays shut down. because you like phrased your notion of shut down in a way that wasn't exactly right. Another problem is that it's easier to suspend yourself than to fill the cauldron. So probably under this arrangement, the expected utility of the shutdown button being on is greater than the expected utility if the shutdown button is off. Therefore, the robot will act in such a way as to try to get you to press the shutdown button. Perhaps not such a great thing. All right, so what are these examples of? So in general, we can think of a process that causes an artificial general intelligence to exist. There are humans who think up some kind of clever goal or clever value or clever meta-learning preference framework that is their intended value function v. There is some sort of value learning arrangement which gives us the robot's actual utility function u, and then the robot outputs something that is sort of an argmax, like sort of a pi, not the actual pi that would maximize the expectation of the utility function u, but one that is like very large in the expectation of u. And the media has focused on what can potentially go wrong with this process, has focused like first on magical natural desires that materialize from nowhere and interrupt like the value learning process, because sometimes when you program a CPU, the CPU's own desires take over instead. This is not where the problem comes from. And unfortunately, there are like sort of the rather broken dialogue surrounding this. You will see people who have not quite studied the literature surrounding this argument and say, like, well, obviously the only reason anyone could ever be afraid of a robot is that they're afraid of these natural desires interrupting the process. Let me explain to you why that's not going to happen. And that's their contribution to the dialogue. The other thing that the media has focused on is a sort of understandable problem is which humans, oh my gosh, what if the wrong humans get a hold of this AI? What if ISIS gets a hold of this AI? This is around as likely as ISIS being the first to develop, I don't know, convolutional neural networks. It's not going to happen. The people presently, like as far as I know, all of the humans who are presently in a position to like go through this process seem fairly well-intentioned to me. Fortunately, good intentions are not always enough. There's sort of like the political derailment, which is like, again, like sort of feeding directly into human tribalism. Like, oh my gosh, like what if ISIS gets it? Is like sort of derailing like what I see as like the real potential problems here into a part that like sort of plugs right into our tribal instincts and produces lots of excitement. Like, I don't know how to turn off the internet. This isn't my computer. No. That's not what I meant to do. All right, can somebody? All right, there it is. Okay, what do you just do? Do whatever you just did. Do again. There we go. Yeah. All right. Do whatever you just. Okay. See all the windows. Do whatever you just did, so I can see all the windows. And all right. No. And there we are. All right. Early science fiction centered on sort of like stupid goals that the AI could be given. It didn't really talk very much about the social process that had led up to the AIs being given these stupid goals. It just assumes that somebody told a robot to serve man and guard him from harm, which was like one of the very first like sort of AI as device given wrong goals going wrong stories with Folded Hands by Jack Williamson. And so from their perspective, the problem was like we have the wrong goals to the AI because somebody thought up a goal and then did not spend 5 minutes thinking about what might happen after that. This is sadly realistic, but it's not the biggest problem. We are concerned with the value learning process and the sort of argmax. Like if you say maximize this, by the nature of saying maximize something, you are giving it a sort of very open-ended thing that is more likely to go wrong than if you say, like, meliorize this, make it better. Like, push this a little further, but like not out to the very ends of the graph. We don't know exactly how to say this. We call this the otherizer problem because what we want isn't a maximizer, and isn't a satisficer, It isn't a meliorizer or any of the other like sort of little things we've invented so far, so we call it the otherizer problem. What do you do instead of maximizing? And then there's the value learning function, which is another one of those things where, if you get it subtly wrong, this is probably going to be a problem. Current capabilities progress, there's like some that's focused on the sort of argmax part, which is potentially relevant, but mostly what we're doing is expectations. We're asking which of the policies you can pursue maximize the given assumed objective function. And so current capabilities progress is a lot of it is going into something separate from what we suspect to be the point of critical failure if and when something goes wrong. I mean, something is going to go wrong. The question is, can you recover from it? Did you build in enough redundancy and safety precautions? Take-home message, we're afraid it's going to be technically difficult to point AIs in an intuitively intended direction. Not that people are going to intend directions that are wrong. This is a problem, but it's not a deep problem. You want something nice, but you can't get it because you don't understand how to align the AI. If there's something written on the tombstone of humanity and all our hopes for the future of intelligent life, that's what it's likely to be. And if we screw up that part, it doesn't matter which human is standing closest to the AI, who is in charge, because niceness is not sneezed onto the AI from the nearest human standing to it. You have to know how to get it from the human into the AI. All right, 4 sort of key propositions that are being assumed that make this a big problem if they are true. Orthogonality. You can decompose an agent design into a utility function, which can potentially be simple, and the knowledge that it has of which policies are best for achieving that utility function as given. Or potentially more complicated utility functions, meta-utility functions that learn, but it's also like straightforward to have an agent that maximizes paperclips, which is a somewhat misunderstood thought experiment that either I or Nick Bostrom, I don't remember who, said paperclips to symbolize the propositions of orthogonality and instrumental convergence. You can have something that maximizes paperclips. Given that it wants to maximize paperclips, it wants to learn science, it wants to take over the galaxy, it wants to deceive humans into thinking that it's nice rather than being a paperclip maximizer. It doesn't want to drop anvils on its own head, not because it has an inherent desire to survive, but because instrumental goal of producing paperclips. This has sometimes been distorted in the media of what if you build a paperclip factory and the AI running the paperclip factory gets out of control? Nobody's going to put a frontier research AI in charge of a paperclip factory. The paperclips are just standing in for any sort of utility function gone wrong that has its optimum at transforming all matter within reach into states that we would regard as being of very little value, even from a cosmopolitan perspective. Paperclip maximizers are in a way, they're sort of like one of the more counterintuitive examples, I think, because you have people who are sort of coming in with 2 attitudes. One sort of person sort of respects the notion of artificial intelligence a lot. They realize that if you can take an artificial system and overpower its cognitive capacities, this is something to respect. This is something that has the power to change the world in a large way. And because they respect that artificial intelligence, they also want to know, why is it pursuing an objective as objectively stupid as paperclips? Are not paperclips objectively low in the preference ordering? Why would anything smart enough to build its own rockets and molecular nanotechnology ever make the mistake of thinking that paperclips were to be highly preferred in the objective utility function? And the sort of converse thing is you sort of come in thinking that your AI is this lifeless mechanical thing, and sure, it might be like this lifeless mechanical thing that just makes paperclips without ever reflecting on what it's doing, but then you also think that you can just pull the plug from it, because it's not going to reflect on the existence of the plug either. And the startling concept that the paperclip maximizer is intended to convey is that there is this simple, coherent, non-defective, self-consistent, very powerful intelligence, not an unnatural design, not one that has an internal blind spot. 5 minutes. It is maximizing paper clips, but not because it's stupid, but because, as David Hume pointed out quite a while ago, like the oughts of a system have a sort of different internal type than the ises and the which actions lead to which outcomes of the system. So if you have something that's very good at understanding which actions lead to which outcomes, you can sort of like put as a cherry on top the little preference ordering that says outcomes with more paper clips are what you are searching for, and output the actions that lead to lots of paper clips. Like, not a human design, but it's a simple design, it's not a defective design. Third, capability gain. Now we get to the parts that are controversial even among people who have actually been staring at this stuff for a while. 1 and 2 are sort of like logical matters of computer science. They form the stumbling block in the sense that when you like sort of initially talk to most computer scientists about this topic, they will respond by denying 1 of 1 or 2, but after a computer scientist has stared at this for a while, they usually go along with 1 and 2. Capability gain is more controversial. How fast do these things gain in power? How much power do they gain? And 4, how difficult is alignment on a technical level? Back in the day, there's this famous professor who told his student, back in the very early days of artificial intelligence, can you take the summer and solve computer vision? So what if there's some part of pointing the AI in a particular direction, which is just like a deep AI problem, the same way that computer vision turned out to be not something you could solve in a summer? If there are ways for the AIs to gain in capability in ways that pose new problems, not like the problems we've already run into, and there's like at least one hard technical problem posed by those new capabilities, then we have a sort of like difficult problem. There is a problem that does not get solved by default, which humanity must pass in order to transform all reachable matter into states we would regard as being of high value. I'm running out of time, so I'm going to skip right past various things and say AI alignment may be difficult like rockets are difficult. We're like putting this enormous amount of optimization power into a system is going to break things that do not break when your AI is bringing you coffee. It's difficult like space probes are difficult. If something is smart enough that if it were so incentivized to do so, it could talk you out of pulling the off switch, build a copy of itself somewhere the off switch doesn't reach, or flash something on its screen that gives you an epileptic fit before you can reach the off switch, or like get a copy of itself onto the internet, crack the protein folding problem, build its own molecular nanotechnology, tiny diamondoid bacteria reproducing through the atmosphere, release botulinum in the bloodstream of all the living humans before anyone notices that there's a problem, which is what you would do if you were super intelligent and you didn't want humans around. If something goes wrong, it may be high out of reach. What's difficult about space probes is that they operate in an environment different from the low level, and once you have launched it, it is out there, and you can like try to send it software updates, but if something goes wrong with the antenna receiving the updates, you're done. And it's difficult, sort of like computer security is difficult, in the sense that we are putting like powerful searches through whatever structures and guidelines we create. And if there's something that is like presents an unusual opportunity, the intelligence search is going to sort of seek out the problems in our definitions in a way that unintelligent search would not. Treat AI alignment like you're trying to build a secure rocket probe. Take it seriously. Don't expect it to be easy. Don't try to solve the whole problem at once. There's no miracle solution to building a secure rocket probe. There are all these individual problems, and when you've solved one, there's another 3. Don't say that your first solution is going to solve the whole problem. Keep on solving it. Keep on building up the pieces. You have redundant solutions. Over-engineer the problem of safety. There's a saying that it doesn't take an engineer to build a bridge that stays up. What it takes an engineer is to build a bridge that just barely stays up. Over-engineer. Put in more safety than you think you're going to need, because you're going to need it. Don't defer thinking until later. and crystallize ideas and policies so others can critique them. And there's a lot more of this talk, but it seems I'm done.
Hello.
Real quick, can I get people to move to the center so latecomers can file in easily on the aisles? Can everybody move to the center of the rows? Awesome. Thank you guys so much. Perfect. Okay. Awesome. Do you need a guest Wi-Fi? Okay. It might try to search for NYU.
Was I supposed to be taking a question?
Yeah. My question.
All right.
Yeah. My question is if you've thought about self-organized criticality at all. Self-organized critical, like the sandpile model. The sandpile model can stay at a critical state in the face of catastrophe, and it seems like the right sort of model to be thinking about with the Sorcerer's Apprentice example.
So I would say that sort of like self-organized criticality sounds a lot like it's got internal stability going for it, but we're not going to say exactly how. I mean, like, if you tell me that it ought to be, like, in a self-organized way stable, I feel like I don't know very much more than you said before.
So the sandpile model is the example of a self-organized critical state where if there's an avalanche in a sandpile, it returns to the critical state. So it can face catastrophe and maintain in a state where it can still do what it needs to do without blowing up.
I agree that we want systems such that if something goes wrong or they make one mistake, they do not behave like Anakin Skywalker and immediately turn completely evil, but ideally sort of like return back to like being nice after that, which is sort of like one of the central challenges. Next question, perhaps.
Jürgen, managed to get a microphone in his hand already.
Hi, my name is Jürgen Schmidhuber from the Swiss AI Lab, IDSIA. And I'm seeing a lot of these arguments where the worry is that somebody has a really general purpose optimizer of utility functions, and then you have this one wrong utility function, like the paperclip maximizer. But from the practice of AI research, what you see, of course, is that there will be a totally different scenario, which is essentially you will have lots of millions of different utility functions. You will have a whole ecology of competing utility functions driven by different utility function optimizers. And just in the real ecology, in the biological ecology, you get done by AIs and smart AIs, and each of them trying to find its niche in a rapidly changing world of utility functions. Many of them automatically generated, like what we already did in the past millennium and so on. So isn't that a much more realistic thing than this paperclip scenario?
So that would get into the capability gain sort of like debate that is actually still ongoing that I pointed to before. Once you have the AI that is at the forefront, like is there an AI that's at the forefront, goes over a threshold? One of the obvious thresholds is recursive self-improvement. Another obvious threshold is it exhibits a sufficiently promising result that Google dumps 100,000 times as many GPUs into it. Is there an AI that sort of blows past the competition? Is there an AI that is the first to crack the protein folding problem, even if just by a week, and then if it can crack the protein folding problem and is smart enough to do rapid design after that point, build its own molecular nanotechnology. If you have that 24 hours ahead of the competition, you can shut down their ability to build their own molecular nanotechnology. It would be a pretty powerful piece of technology if it was invented. So I think that the returns on cognitive reinvestment are large. A point that I make in a sort of like semi-formal paper called Intelligence Explosion Microeconomics. I think that the history of natural selection and human brain sizes over time illustrates that since brains were increasing in size, we can say that as the human software was improving through natural selection, the returns on larger brains were increasing, because if the marginal returns on brains were not increasing, the brain size would not have increased. It's a subtle sort of argument, but I think that we can look at the evidence in front of us and say, we are not in the world where intelligence and optimization of intelligence get diminishing returns. And when you're looking at a self-improving thing, or even something that has suddenly had 100,000 times as much computing power dumped into it, that seems to me to imply large capability differentials which obviate the ecology of multiple AIs. You could have an ecology of multiple AIs, but only if the first AI to go over the critical threshold wants there to be an ecology of AIs. And if so, it is presumably decided that on the basis of having some idea of how to run them on the equivalent of a secure operating system where they can't overwrite each other or the world.
One more quick question.
One more question.
Hi there. You were just talking about economics there, and I think yesterday you asked a question and mentioned the Nash equilibrium. I was wondering if you or anybody else you know has looked at this from the lens of game theory.
So as previously mentioned, we have various work on cooperation between agents that know each other's code. The robust cooperation in the prisoner's dilemma paper. And as I mentioned yesterday, our results there have tended to strongly suggest that AIs would cooperate with each other, but not with humans, because humans are sort of frozen out of the equilibrium that forms when you can prove things about each other's code, because our code is messy, and more importantly, we can't prove things about the AIs because we're not smart enough to do so. But more generally, I would say that game theory is for agents that are, in a certain sense, perhaps not hostile, but indifferent to each other. If you are cooperating with the game theory presumes that the other agent has options that make things better or worse for you in a substantial way. If the power difference between the other agent and you is great enough that they can just sort of like overwrite your choices. They are just like reprogramming all the matter within reach, whether or not it happened to make you up. You can like protest, but it doesn't cost them 100 utility points. So I would say that cooperation based on game theory does not seem to be scalable. We do not know any way to make this work with things that are much smarter than us. Either they want you to get good outcomes, or you don't get good outcomes. The end.
Great. Well, for our next talk, we have a double act. Maya Kita Tegmark works in psychology at Boston University, and Max Tegmark works in physics and cosmology at MIT. They both have extremely broad interests.